You think you know what a hole is. Of course you do. You've seen holes your entire life. There's a hole in your sock. There's a hole in the ground where someone dug up the road. There's a hole in a piece of paper when you push a pencil through it. Holes are everywhere. Holes are obvious. Holes are one of the first things a child learns to point at and name. That thing right there where something is missing, that's a hole. Simple, obvious, not even worth thinking about. Except here's the problem. When you actually stop and think about it, when you actually ask the question that nobody asked, you realize something that should genuinely unsettle you. A hole is not a thing. Not in any physical sense, not in any meaningful sense. A hole has no mass. A hole has no energy. A hole has no atoms. A hole has no weight, no temperature, no charge, no spin. You cannot pick up a hole and put it somewhere else. You cannot build anything out of holes. You cannot measure a hole directly. You can only measure the matter around it and infer that the hole exists because of what the matter is doing, or rather what it is not doing. A hole is defined entirely by absence, by what is not there, by the matter that used to be somewhere and no longer is, or by the matter that surrounds an empty region and gives that region its shape. And this is not a trivial philosophical point. This is not me being clever with words. This is a fundamental statement about the nature of physical reality. When you point at a hole and say, there it is, that thing, you are pointing at nothing, literally nothing, and yet your brain processes it as a something. Your brain assigns it properties, shape, size, depth. Your brain treats the absence of matter as if it were a presence of matter, as if the hole itself were an object in the world, a thing you can see and name and interact with. Why? Why does the brain do that? And more importantly, what does it reveal about how we think about reality? Let me show you. Take a piece of paper. Any piece of paper. Hold it up and look at it. Now take a pencil and push it through. You've made a hole. Now here's the question I want you to actually sit with, rather than just shrug off and move on. Where did the hole come from? Your first instinct is to say the pencil made it. The pencil pushed through the paper and made the hole. But that's not an answer. That's a description of what happened. I want to know where the hole came from in the physical sense. What is the hole made of? What substance entered the paper to create this new feature? The answer is nothing. No substance entered the paper. No material was added. The pencil displaced some paper fibers, compressed others, pushed some aside. What's left is a region of space that is now occupied by air instead of paper. The hole is not a new thing that appeared. The hole is the local absence of paper. It is defined entirely by the paper around it. Without the paper, there is no hole. There's just space everywhere. The hole only exists as a concept because we are comparing the empty region to the surrounding material and noticing the difference. Now follow this thought a little further because it gets stranger very quickly. You can move a hole. You've done this without thinking about it. Take a donut. The hole is in the middle. Now pick up the donut and move it across the table. The hole moved with it, but nothing physical moved to carry the hole. No substance called hole traveled across the table. The matter of the donut moved, and the absence at the center of the donut moved along with it because the hole is defined by the donut structure. The hole is a property of the matter arrangement, not an independent entity. But here's where it becomes genuinely strange. You can also move a hole without moving the matter around it. Think about a line of people standing in a row. One person steps out of line, leaving a gap. That gap is a hole in the line. Now the next person steps into the gap, filling it, but simultaneously creating a new gap where there used to be. The gap moved. It traveled one position down the line. No person moved in the direction the gap traveled. The people only moved sideways, stepping in and out. The gap moved forward all by itself, carried along by a wave of local displacements. The whole moved as an emergent phenomenon, as a pattern, not as a thing but as a behavior, a coordinated absence propagating through a system of presences. If that sounds abstract, let me make it concrete. Because this is not just philosophy. This is exactly what happens inside every semiconductor, inside every computer chip, inside the device you are watching this on right now. In a semiconductor, you have a crystal lattice of atoms with electrons filling most of the available energy states. When an electron gets enough energy to jump to a higher state, it leaves behind a vacancy, an empty state, a hole, and that hole behaves, for all practical purposes, exactly like a particle. It has an effective mass, it has a charge equal and opposite to the electron's charge. It moves through the semiconductor in response to electric fields. It participates in current flow. Engineers track it, they calculate its properties, they design devices around its behavior. The whole is so particle-like that in semiconductor physics it is treated as a genuine quasi-particle. It gets its own symbol, its own equations, its own place in the physics of the system. But it is not a particle, it is an absence of a particle. It is the coordinated propagating gap left behind when an electron moves. The hole moves in one direction precisely because electrons are moving in the other direction, and the absence travels forward as a consequence of those electron displacements. The hole is real in the sense that it has measurable, predictable, quantifiable effects on the behavior of the system. But it is not real in the sense of being a physical object made of substance. It is a pattern and information structure, a description of what is missing and where, and this distinction matters enormously. Not just for semiconductors, for everything, because here is what I want you to really see. The hole in your sock and the hole in a semiconductor are the same kind of thing. They are both absences given the appearance of existence by the matter that surrounds them and the human tendency to treat patterns as objects. Your brain is extraordinarily good at finding patterns. That is one of the things that makes human intelligence so remarkable. We can look at a complex scene and instantly extract the relevant structures, the boundaries, the shapes, the regions. But this same ability that makes us so good at navigating the world also causes us to reify things that are not actually there, to treat the pattern as if it were a substance, to point at the gap in the donut and say there is a thing there, when in physical fact there is nothing there at all. Let me push this even further. Because if you accept that a hole is not a thing, only an absence, you have to confront some deeply uncomfortable questions about other absences you might be reifying without realizing it. What is darkness? Is darkness a thing? No. Darkness is the absence of light. You cannot shine darkness into a bright room. You cannot carry a bucket of darkness and pour it somewhere. Darkness is what remains when photons are not present. It is defined by what is not there. What is silence? Silence is the absence of sound waves. No substance called silence propagates through the air. When a room goes quiet, the air simply stops vibrating in the patterns we call sound. Silence is the default state of a medium. It is the absence of a disturbance. What is cold? Cold is the absence of thermal motion. There is no substance called cold that flows into a room when you open a freezer. There is only the relative absence of kinetic energy in the molecules of the air. When we say something is cold, we mean its atoms are moving slowly. Cold is not a thing. Cold is a comparative lack of something. And now here is where it gets really uncomfortable. Because if you follow this logic far enough, you start to wonder how many of the things you think of as real, positive, substantial presences in the world are actually just absences in disguise. Patterns of missing things that your brain has dressed up as objects because that is the cognitive shortcut that gets you through the day most efficiently. Shadow. A shadow is not a substance. It is a region where light is blocked. When a cloud moves across the sun and the shadow sweeps across the ground, no dark substance travels with it. The shadow is nothing more than the boundary of illumination moving as the cloud moves. And yet shadows have shapes. They have edges. They move with apparent purpose and direction. They look like things. Your visual system processes them as objects because your visual system evolved to extract shapes from visual fields. And a shadow has shape, but there is nothing there. Just a relative absence of photons in a particular region of space. And now go deeper still, because you know what else is an absence? An electron hole in a semiconductor is an absence. But what about the electron itself? If you go deep enough into particle physics, if you push all the way down to quantum field theory, you find something extraordinary. What we call particles, electrons, quarks, photons, all of them. They are not tiny solid balls of substance. They are excitations of quantum fields. They are disturbances. They are the presence of a disturbance in a field that otherwise sits at its ground state. They are, in a sense, the opposite of a hole. A hole is an absence in a sea of presences. A particle is a presence, a localized excitation in a sea of absences, in the ground state of the field. But here is the thing that should make you pause. The Dirac sea picture of quantum field theory, one of the early mathematical frameworks for understanding electrons, literally describes the vacuum, empty space, as a completely filled sea of negative energy electron states. And what we call an electron is an excitation above that sea, while what we call a positron, the antiparticle of the electron, is a hole in that sea, a missing electron state, an absence and a fullness, playing the role of a particle with positive charge. The positron is, in the most technical sense, a hole. A real measurable particle with mass and charge and definite properties is mathematically described as the absence of something. The distinction between something and nothing, between presence and absence, between particle and whole, is not as clean as you thought. It depends on what you define as your baseline, what you call full and what you call empty. Change the baseline and the whole becomes the thing and the thing becomes the whole. This is not wordplay. This is the deep structure of quantum field theory. The vacuum is not empty. The vacuum is a state, a particular configuration of all the quantum fields. And particles are deviations from that state, excitations, disturbances. And whether you call something a particle or a whole depends entirely on how you define the vacuum, the baseline, the thing you compare everything else against. Let that land. The most fundamental objects in the universe, the particles that make up every atom of your body, can be described as wholes, as absences, as regions where the field does something different from its normal nothing. The difference between matter and empty space is, at the deepest level, a difference in the pattern of field excitations. And pattern is not substance, pattern is information. Pattern is structure. Pattern is the thing your brain is extraordinarily good at detecting and naming and treating as if it were a solid, substantial, graspable object in the world. You point at a hole in a piece of paper and say, there it is. And you are not wrong to say so. The hole is real in every practical sense. It has a location, it has a size. You can put your finger through it, you can describe it precisely, and another person will know exactly what you are talking about. The hole is functionally real, but it is not physically real in the way a piece of paper is physically real. It does not have mass, it does not have substance. It is a description of an arrangement of matter, not a piece of matter itself. And the universe, it turns out, is full of things like this. Things that are functionally real, practically real, measurably real, but not substantial in the way we instinctively imagine. Forces that act across empty space with nothing carrying them. Fields that fill all of space with no material medium to wave in. Particles that are excitations of those fields rather than tiny solid spheres. Properties like spin and charge that have no classical counterpart, no picture you can draw, no analogy from everyday experience that captures what they actually are. Reality is not made of stuff in the way you think. Reality is made of patterns in fields, and patterns include absences. Absences can propagate, absences can carry information. Absences can behave like particles and be tracked by engineers and contribute to the flow of current that powers the device you are holding right now. The hole in your sock is not there, not really. And the electrons in your phone are only there in the same sense that the hole in your sock is there. They are patterns, disturbances, deviations from a baseline. The next time you look at a hole, any hole, remember what you are actually looking at. You are looking at the universal structure revealing itself. You are looking at the fact that matter has edges, that matter does not fill all of space, that the arrangement of what is there is just as physically meaningful as what is there. The hole is not nothing. The hole is the shape of the boundary. The hole is the geometry of the absence. And geometry, it turns out, is one of the most powerful forces in the universe. Einstein told us that. Mass curves space-time. The geometry of space tells matter how to move. The curvature of nothing governs the trajectory of everything. A black hole is a region of space-time so severely curved that nothing can escape, not even light. The most dramatic and powerful object in the universe is named after an absence. After the dark region where even light cannot reach. After the hole, there is something in that, something worth sitting with. If you want to keep seeing the world for what it actually is, not what it appears to be, subscribe, because we are just getting started.